Now, two important numericals on circular motion to clarify your concept of tangential acceleration and radial acceleration. The first one, a particle P moves in counterclockwise direction, means anticlockwise. Here is a particle P, it is moving anticlockwise in a circular path. A part of it I have shown here. Counterclockwise direction in a circular path. The moment of a P, how P is moving, is such that it sweeps out a length S is equal to TQ plus 5. As P is moving, say it is going from here to here, then this is the distance it traveled. This distance S is given by T cube plus 5, where T is in seconds, S is in meter, where S is in meter and T is in seconds. The radius of the path is given as 20 meter from here to here, or from here to here, or from here to here. What is the acceleration of the particle P when T is 2 seconds? Now, since it is moving in a circular path, so it will have two kinds of acceleration. That is, one towards the center called radial acceleration and tangential acceleration. But we don't know whether the speed is changing or not with time. So by differentiating this, we will be able to know whether there is tangential acceleration or not. Let AB is a part of a circular path AB, P a point on the path, given S is equal to T cube plus 5, where S a length of the circumference, a length along the circumference. Now if you look here, S depends on time. S depends on time. So differentiating once with respect to time, this will give you velocity. So the velocity is equal to ds over dt. So for S I write tq plus 5, a derivative of tq with respect to time plus derivative of 5 with respect to time. 5 is a constant, so this part becomes 0. 3 comes here, its power is reduced by 1, is 3t square. 3t square plus 0 is 3t square. So that is your velocity. Now if you look at the velocity expression, the velocity also depends on time. Therefore the velocity is changing. Therefore there is acceleration. So the tangential acceleration. Now if you differentiate this, you will have the tangential acceleration. At is dv by dt, derivative of 3t square. 3 comes here, derivative of t square with respect to dt. 2 comes here, power of t is reduced by 1, so it becomes 2t. 3 into 2 is equal to 60. So because the expression is like this, there is a t cube term. So by differentiating once, we get velocity and the power of t is reduced by 1. V again depends on time. So there is the conclusion. So there is acceleration. Velocity is depending on time. So that acceleration is tangential acceleration, which comes out 60. We know the radial or the centripetal acceleration, means towards the center, was always v square over r. V we have found out 3t square. So for v I put 3t square here. 3t square, square of that divided by 20, because r is given as 20. So 90 to the power 4 over 20. So we know tangential acceleration, we know radial acceleration, and we also know these two are perpendicular. And it is asked to find the net acceleration at t is equal to 2 seconds. So at t is equal to 2 seconds, your tangential, which was derived as 60, put t is equal to 2 seconds, is 12 meter per second square. Radial acceleration is v square over r. V square over r. V square of this, that is 9t to the power 4. 9t to the power 4 over the radius. This on simplification gives 7.2. This as well as this both are perpendicular. We know radial acceleration is towards the center, tangential is to this side. Therefore this vector and this vector are perpendicular, so the resultant will be according to parallelogram draw to this side. So this is the net acceleration. So will be square of this plus square of this, square root of that. 80 square plus ar square, square root of that. So I just substitute these two values, 12 and 7.2, take the square, add it, take the square root, 13.99, that is nearly 14 meter per second square. So that was one. Let us do another. The second one is rather more interesting. Now look at. A point moves along an arc of a circle. A point moves. This is a circle. An arc of a circle is also a part of the circle. So therefore it is moving in a circular path. A point moves along an arc of a circle of radius r. Its velocity depends upon the distance covered s, as it is given the velocity at any instant is equal to some constant into square root of the distance it has travelled on the circumference s, where k is a constant. The angle theta between the vector of total acceleration and the tangential acceleration is how much? So look, the radial acceleration is towards the center, we know it is always v square over r. Tangential is always to this side, tangential, that is derivative of v with respect to t. So this as well as this, they are perpendicular, so this is the net acceleration. As per the question, this vector and this vector, what is the angle between them? Theta is equal to how much? Oh, so simple. Now given v is equal to k square root of s. So difference, so we know tangential acceleration is equal to dv by dt. So I differentiate this dv by dt. I rewrite it as like this, dv by ds into ds over dt. This is same thing as this, because ds cancels, we are left with dv by dt. Now by doing so, what do I get? This dv by ds, I keep it as such. Now look at this part, ds over dt, how the distance traveled, displacement is changing with respect to time. So this is equal to your velocity. So this becomes v dv over ds. Now we'll find dv by ds and put it here to find at. Now to find dv by ds, I have to go back here. V is k square root of s. So differentiate this depending on s. So dv by ds is equal to derivative of k square root of s over ds. K is a constant, is taken out. So square root of s I write as s to the power 1 by 2. So k 1 by 2 comes here. The power of s is reduced by 1. So this becomes k by 2. So 1 by 2 minus 1 becomes minus 1 by 2. So I write it as 1 over s to the power 1 by 2. K by 2 remains as such. So this becomes k into 1 k over 2 square root of s. Now, so dv by ds is this much. And at is found out like this. Here there is a term dv by ds. Here I will put this value, which is dv by ds. Therefore your at which is equal to v dv over ds. V dv over ds is equal to this, v remains the same. The value of dv by ds, which I just calculated here, I put it here, k over 2 square root of x, square root of s, sorry. So, and v was given as k square root of s. So for v I put k square root of s. This remains same as this. Now square root of s, square root of k cancels, k into k square over 2 is your tangential acceleration. And radial acceleration we know is always v square over r. And v is given like this, k square root of s. So v square, k square root of s, square of that divided by r. So this becomes k square of this s divided by r. This is your radial acceleration. And tan theta, tan of this angle will be tan of this angle will be this divided by this. This is same thing as your radial acceleration. This is same thing as your tangential acceleration. So tan theta is equal to this, means AR over AT. So your tan theta is AR over AT. I put the value of AR I put the value of 80. So I write it as k square s over r. This 2 comes to the numerator, k square cancels. I have 2s over r. 2s over r. So your tan theta is 2s over r. So theta is tan inverse 2s over r. Theta is tan inverse 2s over r.